optically active, this is glycine. But 19 amino acid, okay, 19 amino acid are optically active, but because glycine is not chiral, so we cannot say that glycine is optically active. And also, we have another properties of amino acid. You know, we have acidic and basic properties of amino acid. I think you are familiar from your high school with the concept of the weak acid and strong acid. Okay. When we say that we have a weak acid, it means that these ionize to the only limited extent, and it's provided reversible dissociation, okay, between your weak acid, it produces a proton and also conjugated base, okay? So you should know that a minus, it means that you have a salt form or conjugate base. And we have a different, for example, sulfuric acid is a strong acid, okay? But some acids, they are considered as a weak, okay? But we have one definition. You remember dissociation constant and pK. Please tell me, whenever you have a strong acid, the value of dissociation constant is excellent, high. What about the pK? Low. Okay? So P in Farsi yani in mathematics. P in mathematical proof yani minus logarithm of, for example, Ka. Okay? So alhamdulillah, you are familiar with this basic concept. About the acidic properties, I want to turn back to the structure of the amino acid. You know, amino acid in aqueous solution, aqueous means that watery solution, okay? In an aqueous solution, they contain weakly acid alpha carboxyl and also weakly basic amino group, okay? Actually in a different solution like aqueous solution. In addition, each of the acidic and basic amino acids sometimes they contain an ionizable group. Which amino acid? Acidic amino acid like aspartate and glutamate, okay? And basic amino acid, for example, lysine and arginine. It means that in addition to carboxyl and amine, acidic amino acid and basic amino acid, they have an ionizable group. They can donate a proton or take a proton. In a physiological pH, both of the NH2 and carboxyl group are completely ionized. Okay, for example, like at this point. What is the name of this compound? This is the Zwitter ion. What is the definition of Zwitter ion? Zwitter ion, the other name is amorpholite, is a neutral molecule. What does it mean neutral? Yani, if you calculate the sum of the negative and positive charge, they're equal. Okay, 0. So, Zwitter ion is a neutral form of your molecule. And about the isoelectric bond, have you ever heard this name? Isoelectric bond, PI. What is it? Isoelectric point. The isoelectric point is an abbreviation of pH of isoelectric. Okay, it means that the pH at which your amino acid is neutral. Okay, So whenever you want to describe the concept of PI يعني the pH of your environment. Sometimes this is, for example, 7, sometimes it's 4, sometimes it's 3, depend on your amino acid, okay? The pH of your environment, that the charge of your amino acid is neutral or 0. As I mentioned here, if you calculate, for example, which form of, for example, these are different form of alanine. For 1, 2, and 3. According to the definition, please tell me which form of, for example, amino acid alanine considered as an isoelectric form or Zwitter ion? Form 2, excellent. Why?
Because it doesn't carry a charge.
What is the net charge here? What about the net charge here? What about this one? Do you understand? Whenever you calculate the net charge of your molecule, whenever it is 0, it's considered as a Zwitter ion, and also it means that you have an isoelectric form. Okay? Isoelectric form is another definition of Zwitter ion. Okay? And as I mentioned, we have one carboxyl group here and one amine group here. Then we can take a proton or actually release a proton, it's considered as an ionizable group. Okay? So carboxyl is an ionizable group because it can present in a COO minus or COOH. This is protonated form, this is deprotonated form. So we can say that carboxyl is an ionizable group. Can release a proton and take a proton, okay? And for example, about another hand of the amine. Sometimes present in an NH2, sometimes present in NH3+. This is a deprotonated form, this is a protonated form. So carboxyl and amine, as I mentioned, they consider as a ionizable group. Okay? But for all of the neutral amino acid, glycine, valine, cysteine, I don't know, serine, threonine, phenylalanine, tyrosine, tryptophan, all of them, because they cannot participate, our group cannot participate in a releasing and actually taking the proton, they consider as a generally simple amino acid. Okay, but we have another type, acidic amino acid and basic. I will explain in the next slide. Are you familiar with this equation? Yes. Henderson-Hasselbalch equation. Please tell me at which position pH is equal pK? Midpoint. What happened at the midpoint? According to this formula.
Negative equals HA.
Excellent. Whenever conjugated base, whenever the concentration of conjugated base is equal to your acid, the logarithm is 0, so you have an equal pH to the pK. This is a Henderson-Hasselbalch equation. And it is very important in a buffer system, you know, the maximum buffering capacity take place at which point? Whenever you have an equal conjugated base and equal acid. This is a titration curve. I ask you about this curve. Are you familiar with this curve? Titration. Really? Alhamdulillah. Yes? most of the time because some of the students are not familiar, and more than half an hour I kill myself to explain this curve.
Teacher, explain it to us.
Who can explain this curve? It's very simple word. Joanna. I want to explain a detail. Yes. Do you want to explain? Just a little.
Okay, so from
At first, please tell me, what are the components of this curve? Concentration of hydroxyl against
the acids, the concentration.
pH.
So from 0 to from 0 to 1, there's no change happens. So the curve is at lowest. And from 1 to above, there's a change happens. So it's in the highest. In the middle, or 0.5.
Wait. Your friend mentioned that, as you can see here, there is a limited change in the pH. What does it mean? Excellent, buffer. Yani buffering happen. Okay? Continue.
Okay, so from point 0.5, this is the maximum point or the saturation curve point, where the pH will equal pKa.
Excellent. Many thanks for your explanation. So, as you can see here, this is the gradual addition of hydroxyl amine base. For example, in the first session, I know Dr. Emanueli had this experiment, titration of the unknown actually acid. At first, you take a full acid, okay? You add a drop by drop OH. Do you remember? When you add actually drop by drop, and you take some pH indicator, okay? You think that, suddenly the pH change, the color change and disappear. You know, the solution resists against the pH change. As you can see here, the slope of your curve is very slow. As you know, this is the blue box are buffering system. And as your friend mentioned about the definition of the isoelectric pH, he mentioned that at the middle of your curve, you know, and how can I calculate the isoelectric pH? One of your sample question is calculating the isoelectric pH for all type of amino acid. Okay? Do you have any question? So, no?
I have one.
Yes.
Buffer, the job of buffer is the still the pH don't change. But you say when the crate is changed, it's having buffer.
What you mean? Buffer is the molecule. Buffering region. You want to explain the 1 plus and 1 minus? I will explain this at first. Wait, okay? At first, I want to recall your attention for calculation of the isoelectric pH. Okay. At first, you should know that for each amino acid, for example, for all 20 amino acids, you have a specific PI or isoelectric pH. In your final exam, maybe I ask you to calculate the isoelectric pH. How can we calculate? So, at first, you should know that, for example, this is the titration curve of the glycine. You start, before calculation, I want to explain this curve and what happened during this curve. As I mentioned, you take a fully protonated molecule. What does it mean? The pH is very low, fully acidic. Yani NH3+, full of proton, okay? You added drop by drop OH here. So please tell me, you have a 2 group here that they can act as an acid. Yani they can release a proton. But please tell me, which one at first release a proton? This group or this group? NH3 plus or COH? Why?
Because
A stronger acid, okay? And also we can say that if we compare the pK, this is the pK for COOH, this is the pK for amine group. And according to the pK, I can guess that which one is stronger. The lowest is stronger. So, at first, the first proton release, as you can see here. And what is the net charge here? Net charge.
negative.
Oh,
Zero.
zero. So this form is Zwitter ion or PI form. Am I right? So you are here. Do you understand? You added more OH, more NaOH. What happened? The second ionizable group releases its proton. Okay? Do you understand? So, at first, what is the point here? At first, you should know that whenever you have a neutral amino acid, yani glycine, serine, threonine, all kind of these amino acid, they have a two-step in their titration curve. Okay? Why? Because they have only two ionizable groups. For each ionizable group, one step. A step, do you know some step? Okay? So, what about the calculation? If I ask you to calculate the isoelectric pH, about mathematical, you should actually follow this formula. Put the pK of your carboxyl plus pK of your amine group divided by 2. So, yani in a simple word, this is the average of 2 pK. Do you understand? It is very simple, and most of the time in your final exam, I give you calculate the isoelectric pH or PI. You should, according to this formula, actually reach to the pH isoelectric. But about your question, as your friend mentioned, we have this blue box, and we have a range pH plus 1 and minus 1. What does it mean?
Like the buffer cannot go more than one or less, basically.
So it means that this is a buffering region. Okay? So as you can see here, the change of the pH is very slow. But whenever you exit this chart, it means that you exit from the buffering region. And suddenly you have a change in a pH. Do you understand? Okay. About another amino acid, you know, we have a 3 sample question. Sometimes I ask you to calculate the PI of neutral amino acid. Sometimes I ask you to calculate the PI of the basic amino acid. The detail is not important, just know that whenever you want to calculate the PI or isoelectric pH of basic amino acid, especially I ask you about lysine and arginine, okay? How can I calculate? So as you can see here, instead of pK of carboxyl, you should put the pK of your R group. You know? H, carboxyl, amine group. Am I right? And also you have an R group here. You have a one pK here, another pK here, for example, pK1, pK2. Oh, it's better to mention that pKCOH, pKNH3, and this now as a pKr. Okay? For calculation of the basic amino acid, you should put the pK of R plus pK of carboxyl or amine, because this is base. As you know, in the structure of the R group of basic amino acid, you have a carboxyl. So this one important and this one, and divided by 2. Do you understand? For example, if this is imaginary value, whenever this is 3, this is 9, and this is 10, how can I calculate the isoelectric pH of the lysine, for example? 10 plus 9 divided by 2. Do you understand? You should ignore the carboxyl because this is basic amino acid. Do you understand? And about acidic amino acid, in contrast, you should consider pK of R and pK of carboxyl. Do you understand? So, we have a three-way for calculation of the pH of isoelectric or PI. For neutral, pK amine, pK carboxyl. For acidic amino acid, pK R, pK carboxyl. For basic amino acid, pK R, pK amine group. About the structure of the protein, we have it, are familiar in your high school or not?
No.
4-level structure of the amino acid. Okay, at first we have a primary structure. Primary structure in Farsi we say kasbi, sobhe, sobhe, as you know, I cannot pronounce. Okay, these are the actually constituents of the protein, yani different amino acid, they bind together in a linear fashion, okay? And they form a line, for example. This is the first level of structure of the protein, okay? For example, please tell me, recall the carbohydrate session, because these are important for your final exam, about the name of the bond between monosaccharide. Disaccharide, yes, 4. But what is the name of the link? What is the name of the bond?
Hydrogen bond?
No. Glycosidic bond. Excellent. Glycosidic bond. Okay? But about the name of the bond between amino acid, this is peptide bond actually. Okay? Peptide bond is a covalent. Covalent is a strong or weak? Strong. Okay? Covalent classified as a strong bond. So, amino acid, they bind together through the peptide bond. So, what is the important at first point? The name of the bond, this is peptide bond. This is a strong and covalent bond. You know, for example, this amino acid bonds bind to this amino acid. One of the hand is COH here, another hand is NH2, for example. Following release of atoms of water, what is the result? C. Double bond O and NH, and this amino acid so connect to the another one. Do you understand? So this is a peptide bond. Yes, question? Really?
Yeah.
You know, this is one amino acid, okay? And the hand is carboxyl, okay? The other amino acid, the hand is NH2, for example. They want to make a link, okay? After releasing of OH from here and one H here, OH plus H yani H2O, water.
Yes.
So what is the remaining structure? C, double bond O, NH. So this is a very strong peptide bond.